Hi everybody, Brad McCullough here. I want to tell you a little story. This is a story with a client that I worked with, a really small plant, not a lot of money to spend, but they needed help. This was a drywall mud plant, okay? And I went to work in there and they had a lot of problems getting the mud, you know, they went through mixing and then they, curing and packaging and those kinds of things. So this works for small plants, people that can't have a big system and lots of data, but you can still really drive a lot of improvement. And it also works for us a lot of times with a big client on the front end when we don't have a lot of data, but we're implementing our solutions. We can get started and get some traction early on to try to help. So I want to talk just a little bit about that. This is something that you can do at any plant, any size, and get some traction and deliver some better asset performance because of it. So let's just take a quick look. So, simple approach. I've talked about failure by name before. Max Smith was a reliability guy that taught me this concept back in the 90s, and I've implemented it in several different times. So, first step, you don't have any data, so we go and we gather data. We talk to operations people, the current maintenance team, people out on the floor, and ask them, what's going on? Try to identify what the problems are, right? They know, and if I hear it enough times, I know what the problems are. We document the top problem assets. Here we make a list, 10, 15 of them. The old 80-20 rule applies a lot here, so very, very useful. We document the name of the top failures by asset, and I'll show you what that looks like in a little bit. So we're getting a little more granular about how they break, right? Determine each failure, countermeasure. What are we going to do about it? So this gearbox breaks a lot. What are we going to do? Cause and effect thing. So we're very granular about where the problems are, what we're going to do about them. Now we're not solving all the plant's problems here. We're attacking the 20. We're attacking the 20% of the problems that are creating the biggest challenge for the plant. We implement the countermeasures. We'll validate the success. And then we'll expand the program. So I've done this before, done this with clients, helped clients implement this. And it works really well. It's very pragmatic. So let me just show you. So what do we do when we implement? You've got the steps. That's easy. You can follow 1, 2, 3 and do the steps. But what's the solution really look like? The first thing, we'll put a reliability person in place. So this is a person that walks the floor, really gathers the data, the interview data, takes pictures, looks at problems. And this person is, for all intents and purposes, the maintenance strategist, if you will. And then the second person on the team is a planner scheduler. So this person's responsible to train and implement the solutions. Now, I describe these as distinct roles, but really they ham and egg it. They work together. They are a team to drive these maintenance strategies to these top failing points, right? So they can be on your team, somebody that gets the job by name, or you can go and add jobs depending on the size of your plant and the impact that you're trying to make. So there's a lot of ways to implement it. And then this is what the data looks like. This is how we collected the data, and you can use these examples. So you kind of here's the asset name. This can be a section of a conveyor. This was a mud plant. It was basically a conveyor all the way from mixing to packaging and shipping, and a little bit of robotics and stuff in there. So you could, by section, you could talk about what they were doing in the section, pouring, or it could be a subsystem. So this changes. If the heat treat furnace, it's different. If it's a CNC machine, it's a little different, but you get the idea. So we write down the name, we write down the subsystem, we write down the component that failed. Now there's a lot of data behind this that the reliability guy's capturing. He's writing this down. And then we, through the interviews, either if they have data or they don't, estimate how many failures a year. And then if you really understand the process, you can kind of start to quantify what it's costing you per year. So they're real important. One of the things that Max Smith was really big about with failure by name was you don't want the cure to be more expensive than the cause, right? So if I have a failure that, and you can see one of the countermeasures might be run to failure. If I have a failure, it takes me 1 second to fix. I'm not going to spend $1 million to fix it. So you'll go through and you'll create this list. And then here, am I going to do preventive maintenance? And then, you'll have some details here, but there'll be a PM plan written. Am I going to use predictive technologies because it's a hidden failure and I need to uncover it and know, when it's coming? Operator-driven reliability. Am I going to give some work to operators? Hey, you need to keep this clean. This will help eliminate the problem, and you give them some activities, or checking pressures, checking oil, changing oils, whatever the operators can do. Or am I going to re-engineer it? Engineered solution is one. So sometimes we run across problems that the OEM design wasn't right, and we need to redesign it. And we do a lot of that here at ATS in our repair facility and that, and if you look at some of the other videos, you'll see some of the things that we've done. Or in some cases, I'm going to run to failure. So we put a couple people in place for this little mud plant. We implemented a solution. We executed this process. No data, not much in systems, nothing, right? And we started implementing this thing. And in 2 months, the controller of the plant reported that in month 2, we'd saved them $30,000 in production related delays and so on. So this works. It's very granular. It isn't a solution for a whole plant, but using the 80-20 rule, if you're a small plant and you can't afford a lot of things, but you really want to get some traction, you want to make something happen, or if you're at the front end of a bigger implementation, but you need to show that you can implement some things and prove that you're going to impact asset performance, this is a good way to do it. Hey, just a reminder, in April I'm going to be in Louisville at the Reliable Plant Show. If you get a chance to come by, we're going to talk about OEE and improving asset performance from a financial perspective, a little 30-minute talk. Love to see you there, stop by. And as always, oops, sorry, wrong button. As always, you can reach me at bmccully@advancedtech.com. There's my phone number. I also have a YouTube channel with all my videos on it, and or you can hook up with me on LinkedIn. I appreciate it. Let me know if I can help. Hope this helps you. Feel free to give me a yell. Have a great day. Thanks.